All right, so the first one, which of the following series converges? So that means only one of these converge, all the rest diverge, which is a nice break from those Roman numeral questions where it was which of the following converge? You had to test, all of them, and then your choices were like 1 and 3 and stuff like that. 4 of these are going to diverge, and one of them is going to converge. So I'm going to show you the one that does converge first, and then we'll look at why the other ones don't. The answer for this one is E. This is the one that's going to converge. So if we want to do a comparison, we're going to compare to the series, and I'm just going to look at like who's in charge here. This is 3n squared. I'm actually going to leave off the 3 as well. Just look at the variable here. N squared over n to the 4th. So I'm going to compare that to 1 over n squared. 2 of the n's would cancel. We're just keeping the most important parts, like the who's in charge here. All right, so 1 over n squared, and so that is a p series with p equals 2, and so that converges because 2 is bigger than 1. So if it's bigger than 1, then it's going to converge. So I know that this one converges, and so this one's going to as well. And I would do the limit comparison. And honestly, you don't even need to do this really because no one's going to check your work for multiple choice. As long as you get the right answer, no one's going to know. But for the sake of being thorough, we do a limit of this one over this one. So it would be 3n squared over n to the 4th plus 2n. That is all over 1 over n squared. So let me move it over here where there's less glare. So that looks super fun. But what's going to happen is when you divide by a fraction, you're going to multiply by the reciprocal. So this is going to flip. So we're going to have 3n squared over n to the 4th plus 2n times n squared over 1. And so in the numerator, you would have 3n to the 4th. And in the denominator, you would have 1n to the 4th. So if you're using the coefficients there, 3 over 1 would be 3. And again, as long as that comes out to a finite positive number, then whatever this one does, the other one does as well. So since this was a p series, p was 2, it converges. This one also converges. So just to look, I don't want to spend too much time on the ones that are the wrong answers, but just to go through these. This first one, we can use the nth term test. If you do limit as n goes to infinity for this, we have 3n over 1n, that's going to go to 3. If that comes out to anything other than 0, then the series diverges. So if that comes out to anything other than 0, it diverges. All the rest of these, and if you did limit as n goes to infinity for all the rest of these, you would get 0, which means no conclusion. It means you have to, do some other sort of test, like the integral test or a comparison test. All 3 of these, you would compare to, because these are all very similar. You would compare to 1 over n. They all have an n over an n squared, or I guess this one is n squared over n cubed, but in any case, they can all reduce to 1 over n. And so that's the harmonic series, or a p series where p equals 1, so that diverges. And I'm not going to go through the limits like this for every single one of these, but if you did the limit of any one of these series over 1 over n, it's going to flip this n back to the numerator. So like this one, you'd have 3n squared over n squared. Same with this one. Here you'd have 3n cubed over n cubed. All of those limits are going to end up going to 3, exactly the same as this one did. And so since that's a finite positive number, since this one diverges, all 3 of those are going to also diverge. So again, those are why those are not the answer. So the answer for that one was E. All right, number 2. Which of the following series can be used with limit comparison test to compare to this series? So we have an n squared over an n cubed that's going to reduce to 1 over n, and so that one is going to be A. And so you can go further and do a limit and show that it comes out to a finite positive number. But again, if it's multiple choice, no one's going to be checking that work. And as long as you get the right answer on the AP exam, you know, you don't have to show that. All right, so number 3. So we have these series AN and BN. They're both positive for n's greater than or equal to 1. So if summing up from 1 to infinity of A sub n converges, which of the following must be true? So if that one converges, the other one is going to also converge as long as it's smaller. So if B sub n is smaller than A sub n, if this one converges, then this one is going to converge as well. So I need to find a choice that says that, which is C. If B sub n is smaller than A sub n, then B sub n is also going to converge. So that one is C. All right, number 4. Now this time they tell us which one is smaller than which. So B sub n is smaller than A sub n. So which of the following must be true? So the 2 ways this could go, let me cover up the choices and we'll just look at what was given here. If the smaller one, so if B diverges, then A is also going to diverge. Or if A sub n converges, that's the bigger one, then B sub n is also going to converge. So let me see which one says that, and that one's going to be B. So they wrote it a little bit strangely here. If A sub n converges, again, that's the bigger one, then B sub n is also going to converge, which means that the limit as n goes to infinity would be 0. And that's from the nth term test. Remember, if that limit comes out to anything other than 0, then it's going to diverge. Let me go over the nth term test again here, though, just because that is such a subtle difference. So the nth term test says, if the limit as n goes to infinity of a series, if that comes out to anything other than 0, if it goes to infinity or if it's any other number in the world besides 0, then the series diverges. And if the limit as n goes to infinity of that series does equal 0, then you get no conclusion. So if you want to prove that the series converges, you have to do something else, like a comparison test or an alternating series test, an integral test, you know, some other test. But if you go to flip this around, if the series converges, then that limit will have to be 0. So the limit being 0 isn't enough to prove convergence, but if you do have convergence, then you know the limit is going to have to be 0. And I get that that's a really subtle difference with twisting that around. But again, just because the limit goes to 0, you really can't prove anything from that. But if you already know that it converges, then that limit is going to have to go to 0. Because if it comes out to anything else, then the series doesn't converge, it diverges. All right, so number 5, if the series from 1 to infinity of A sub n diverges, and this is true. Okay, so A sub n is the smaller one. So if we know that that one diverges, then the bigger one is going to diverge as well. So I want to pick whichever choice here says that this series also diverges, which is going to be this one. So it'll be E. All right, and then last one, which of the following statements about this series is true? Letter A, diverges by the nth term test. Well, that means that this limit would need to come out to something other than 0. But as n goes to infinity, this exponential is growing so much bigger than this exponential. This denominator is going to be astronomically large. So you end up with like 1 trillionth, and so that is going to go to 0. So we don't get that it diverges. We don't know necessarily that it converges, but we know that it doesn't diverge. So it can't be that one. And then I think the rest of these are all comparison tests. So we just need to pick which one of these we could compare to. And so if we're looking at like who's in charge here, it's the 2 to the n over 3 to the n, which you can rewrite as 2/3 to the nth power. So it is going to be this one right here. So that one is D.